Welcome to this edition of Fuel for Thought. I'm your host, Guido Vildozo, and today we're diving into a topic that's critical to the future of the automotive industry: rare earth elements and their far-reaching implications for electric vehicles. As many of you know, rare earth elements, or REEs, are essential components in the manufacturing of electric vehicle parts, particularly traction motors. However, the landscape of this market is heavily influenced by China, which currently dominates both the production and processing of these vital materials. In today's conversation, we'll explore how China's control over the rare earth supply chain impacts global industries, the geopolitical ramifications of this dominance, and the responses from other nations as they seek to diversify their sources of REEs. We'll also discuss emerging technologies and the shift towards magnet-free motor technology in Europe, as well as what the future holds for the automotive industry in terms of REE dependency. Joining me today are two experts in the field, Kartik Ganesh and Ji Yang. They will share their insights and perspectives on these pressing issues. So, let's get started. Kartik, good morning, and good afternoon to you, actually. Can you explain what rare earth elements, or REEs, are and why they are essential for electric vehicle components and traction motors?
Good afternoon. So, rare earth elements or REEs comprise a group of 17 elements. These elements are often dispersed and difficult to extract economically. They possess unique magnetic and electrochemical properties that make them indispensable in various high tech applications. In the realm of electric vehicles, rare earth elements are particularly critical for traction motors. These motors rely heavily on magnets made from neodymium, dysprosium, and terbium, which enhance their efficiency and performance. For instance, neodymium magnets are essential for creating strong magnetic fields, while dysprosium and terbium improve the thermal stability of these magnets, making them more efficient under high temperatures.
Thank you. Ji, good evening. China currently dominates the REE market. What factors have contributed to this dominance, and how does it affect global supply chains?
Hi, good morning to you. So I want to put forward a few numbers first, just so the audience understand China's dominance in the rare earth industry. So China's rare earth reserves are the largest in the world, accounting for about 30% to 40% of the total reserves in the entire world, and about 90% of the world's rare earth refining or separation process is actually done in China. And more than 60% of final products are made in China. What's more is that China's the only country that could cover the entire production chain of rare earths. If we look back in history, China's rare earth industry started to take off in the late 80s to 90s after massive reserves were found some years before that. Lower pricing was a key factor that helped China to gain advantages over other countries. And another thing is less stringent environmental regulation in the early days. That also helped to keep the cost of rare earth production down in China. China was the absolute dominant supplier of REs before the year 2010. Then other countries tried to build or rebuild their rare earth industry after 2010, but it's difficult to keep their costs down. One example is that in the US, declining price along with environmental concerns were the main reasons that led to shutdown of mine facilities about 10 years ago from now. Now, even environmental regulations are picking up in China, and we see imports of mined rare earths coming from abroad. But still, China's rare earth products remain the most competitive in both price and quality. And China also produces a huge number of magnets containing rare earth elements that are used by motors and speakers, etc., which makes China quite irreplaceable when it comes to rare earth production.
Thank you for that background. Kartik, what are the geopolitical implications of China's control over the REE supply chain, particularly the automotive industry?
So, China's control over rare earth elements supply chain presents a significant geopolitical implication, especially for industries that are heavily reliant on these materials, such as automotive manufacturing. with China producing over 60% of the world's rare earth and nearly 90% of its processing capacity. It holds a strategic advantage that can be leveraged in international relations. When we talk about the automotive industry, this control can lead to supply chain bottlenecks, increased costs, and potential restrictions on exports, making the industry vulnerable to geopolitical tensions and trade wars. The industry is increasingly recognizing the need to diversify its supply sources and reduce dependence on a single country, which could lead to a more fragmented and complex global supply chain landscape.
Thank you for that. Shifting over to G, can you go over the highlights of China's revised licensing process for REE exports?
Yeah, sure. So in April 2025, basically several months ago, China's Ministry of Commerce announced the decision to implement the export licensing process on medium and heavy rare earth products. Several elements have been put under strict export controls. Currently, all of those 7 rare earth elements, and also primarily products that contain those elements, require a export license to be shipped outside of China, which include magnets for permanent magnet motors and many other applications in vehicles, but exclude the electric motors or rotors that have the same magnets inside. This basically means that shipping magnets or rare earth elements to another country for motor or rotor assembly requires a license. But if the assembly of motor, rotor, or speakers or whatever happened in China, it's exempt from export licensing. So, and to acquire this license, companies need to provide end user information and proof of usage. In the first 1 month or so after the ruling was announced, there were confusions and delays of export as companies were not sure about what materials they need to prepare to apply the license. And even rare earth products that are not supposed to be affected by the licensing process are being held up at the port sometimes. And sometimes they're required to provide further information to prove that those products do not contain any of those restricted rare earth elements. But now we see the process are being simplified to allow for rare earth products to be shipped out of China faster, basically to ease the strain that's put onto global automotive supply chain.
Let me develop a little further. Would you please provide some insight into how has this process affected the automotive supply chain, particularly as it refers to U.S. car manufacturers?
Yes, of course. So basically, this process affected all OEMs and suppliers which are exporting rare earth products or magnets from China. Automotive companies all over the world sounded alarms and warned their business partners of possible supply chain disruptions. We did see several OEMs had to halt production for certain local models to cope with the situation. But US OEMs have a more challenging situation than OEMs from other regions, basically due to trade tension between the US and China. But as I mentioned, there has been a relief to this situation. Rare earth magnets export from China to the US in June, that is last month, so grew by more than 6 times compared to the volume in May. This is part of the results from the trade negotiations between China and the US. Although worth noting here is that this export volume of June this year is still significantly lower than that of June last year. Export of magnets in July this month is likely to continue growing compared to last month because more licenses are being obtained by relevant companies now.
Powerful background. Thank you. Karthik, when it comes to the supply chain, other nations are seeking to diversify their sources of REEs. What strategies are they employing to achieve this, and how effective have they been so far?
So, in response to the challenges posed by China's dominance in the rare earth market, nations like United States, India, Australia, and members of the European Union are actively seeking to diversify their sources of rare earth elements. One primary strategy involves investing in domestic mining projects to establish local supply chains. For example, the United States is working to revive its rare earth mining capabilities, with the Mountain Pass mine in California being a focal point for domestic production. Another approach is investing in research and development to find alternative materials or technologies that can reduce reliance on specific rare earth elements. While there have been some investments and initiatives, replicating China's infrastructure and expertise remains a significant challenge and progress has been slow in establishing a robust alternative supply chain.
With significant R&D efforts to reduce reliance on dysprosium and terbium, what advancements have been made?
So removing rare earths from motors has long been part of the efforts to reduce costs. And now with this renewed potential supply chain risks, there are more talks around this topic, honestly. But to be 100% rare earth free is very, very difficult. Rare earths, heavy rare earths free is what a lot of players in the industry are exploring right now. Tesla did announce their intention to go rare earth free a couple of years ago, and motor producers in China are also investigating this possibility. It's possible to remove heavy rare earths like dysprosium and terbium for smaller motors, but it's difficult to do for traction motors because higher performance are required for those type of motors.
Let's elaborate on that a little bit further, Ji. What are the challenges behind this?
The challenges basically are removing dysprosium requires a motor temperature to be kept under 140 or 150 Celsius, else the magnetization could happen and render the motor basically useless. But keeping motor temperature low requires a motor cooling system to be optimized to cope with high heat generation situations like during rapid acceleration and also regenerative braking. So some motor manufacturers in China, they're developing permanent magnet motors that are free of dysprosium and terbium by trying to keep the motor temperature down. However, no companies have yet successfully launched heavy rare earth traction motor as of now.
Very interesting. Thank you. Kartik, you were talking about Australia, US, and some of the other nations that are trying to work on diversifying their supply chain. Can you discuss the initiatives being taken in North America and India to establish domestic REE extraction and production?
Yes, of course. So, North America and India are making significant strides in investing in mining projects to extract rare earth elements domestically, with the goal of reducing reliance on imports and enhancing regional control over the supply chain. So, in North America, recently, MP Materials announced a public private partnership with the US Department of Defense. The intent of this collaboration was to bolster domestic production capabilities and ensure a stable supply of rare earth elements for various sectors. Such partnerships are crucial as they not only provide funding and resources, but also foster innovation in refining techniques and technologies. In India, the government has circulated a subsidy scheme designed to promote domestic manufacturing of rare earth elements. This initiative encourages private companies to engage in the exploration and extraction of rare earth elements, aiming to develop a self sufficient supply chain within the country. By providing financial incentives, the government hopes to attract investment and expertise in this critical sector. Both regions recognize that establishing domestic production capabilities is essential for mitigating the risks associated with dependence on foreign suppliers, particularly in light of the recent geopolitical tensions. By focusing on local extraction and refining, North America and India are positioning themselves to enhance their competitiveness in the global market for electric vehicles.
Let's focus on Europe. Are they currently leading a shift towards magnet-free motor technology? Why this approach?
Yes, Europe is at the forefront of the shift towards magnet free motor technology for several compelling reasons. First, the automotive industry in Europe is increasingly aware of the vulnerabilities associated with relying on rare earth elements, particularly those sourced from China. By moving towards magnet free technologies such as externally excited synchronous motors, manufacturers can significantly reduce their dependence on rare earth materials, which are not only costly but also subject to geopolitical risks. This shift aligns with Europe's broader sustainability goals. The European Union has set ambitious targets for reducing carbon emissions and promoting environmentally friendly technologies. By adopting magnet free motor designs, which can be more easily produced using locally available materials, manufacturers can enhance the sustainability of their supply chains while also meeting regulatory requirements. The transition to magnet free technologies fosters innovation within the industry as well. As we've seen, companies such as BMW and Renault are leading the way in developing these alternatives, which can potentially offer performance benefits such as improved efficiency and reduced weight.
Thank you for the insight, Kartik. Let's elaborate on this a little bit more. I would assume that there are implications to this transition for the automotive supply chain. Would you please elaborate on some of these?
Absolutely. The transition to magnet-free motor technology has significant implications for the automotive supply chain. First, it allows for diversification by reducing reliance on rare earth materials, which helps mitigate risks associated with sourcing from countries like China. This diversification enhances supply chain resilience, enabling automakers to better navigate geopolitical tensions. Additionally, magnet-free motors utilize more readily available materials such as copper and aluminum, which can lead to more localized supply chains. As manufacturers adopt these new technologies, they may need to invest in upgrading production facilities. While this could increase short term capital expenditure, it may yield long term savings by decreasing the dependence on costly rare earth materials. Finally, the transition is likely to spur competition among suppliers and manufacturers as they innovate to capture market share in the evolving electric vehicle landscape. Overall, while challenges exist, this shift presents opportunities for greater efficiency, sustainability, and resilience in the automotive supply chain.
One last point, Kartik. Current projections suggest a significant shift towards alternative technologies in traction motors. What are your predictions for the industry in the next 5 to 10 years regarding our REE dependency?
In the next 5 to 10 years, the automotive industry will see a gradual but significant shift in its dependency on rare earth elements. As the demand for electric vehicles continues to grow, manufacturers will increasingly focus on developing alternate technologies that reduce reliance on specific rare earths. However, while there will be advancements in alternate technologies, the transition will not be immediate. The existing electric vehicle models and their associated supply chains are deeply integrated with rare earth element dependent components, making it challenging to completely eliminate reliance on these materials in the short run. Therefore, it is likely that rare earth elements will still play a significant role in the industry for several years, particularly in high performance applications where their unique properties are difficult to replicate.
Thank you. G. What long term risks should the automotive industry be aware of as it navigates the evolving landscape of REE?
I think as all involved parties have familiarized themselves with the licensing process and the process itself being optimized at the same time, we see less strain on the supply chain of magnets now. But those rare earth products are still being shipped out at a slower pace than before the licensing process was in place. This is likely to improve in the following months, but because rare earths is such an important bargaining chip for China, and for the foreseeable future, the trade tension between China and the US is not going to go away anytime soon. So there's always the possibility of another supply chain disruption given automotive industry's dependency magnets made in China.
Thank you for that. And finally, if we were to place ourselves in the shoes of our customers, how can companies prepare for these challenges, G?
To answer this question, I think stock up magnets and rare earths would be the first thing that comes to mind. And diversifying supply chain could help companies to be better prepared for possible risks. However, steering the entire rare earth supply chain away from China is pretty much impossible for the near future. When mining capacity, as Kartik mentioned before, is being expanded in the US and other regions as well. But oftentimes we see that processing of those mined rare earths still needs to be done in China. So the situation could be different in the long term, but I don't think it is going to happen in the next few years. Another measure is to leverage magnet-free motors such as ESM and increase its share could help to reduce potential effects of another rare earth crisis. Another approach that's being considered by some is to move rotor production to China so they are exempt from this export licensing. And in general, OEMs and suppliers should expect longer delivery time and possible disruption for receiving magnets. And they need to basically plan ahead more. Increasing inventory for rare earth products could alleviate possible strains on the supply chain, basically.
Thank you so much, Kartik and G. This has been incredibly timely and insightful, and I have learned a lot from you today. To our listeners, thank you for joining us for this insightful episode of Food for Thought. Today, we've unpacked the complexity surrounding rare earth elements and their crucial role in the automotive industry, particularly as we transition towards electric vehicles. We've heard from our guests about China's significant influence on the REE market, the geopolitical implications of this control, and how various nations are striving to establish their own supply chains. We've also explored the exciting technological advancements taking place, especially Europe moving towards magnet-free motors. As we look ahead, the questions remain. How will the automotive industry navigate the evolving landscape of rare earth elements? What strategies will companies employ to ensure a sustainable and resilient supply chain? We appreciate our guests for sharing their expertise, and thank you to our listeners for tuning in. Don't forget to follow us on LinkedIn at S&P Global Mobility and explore our products and offerings at spglobal.com/mobility. We'll be back for more Fuel for Thought next month. To those of you in the Northern Hemisphere, I hope you're enjoying the longer and warmer days. Have a great day. Thank you.